Today I continue the video about MIP construction. In the previous video I showed you how to create MIP. If you didn't watch the video, I give you the link above to see it. In particular, today I'll show you how to create the part of the MIP workable with CNC 3018. So I'll use a method that I thought and believe could work. But now I move to the computer to see how to do it. First of all, I open the MIP project with Fusion 360 and I turn off all frontal panels of MIP. After that, I create a new sketch on this face. I make a rectangle. The size is 160 for 209. It will be the size I'll work for building the MIP. Okay, now I have to select all four size rectangle. I click on create and select the rectangular pattern. Is 1485 millimeters. Now I set 10 parts in length. After that, I click this arrow and pull it down like that. Okay, now it appears 3 rectangles, but I set only 2. And here I set height 209. After these steps, I see an overview of MIP parts. I'll have to work with a CNC. Now I'm going to make a little joint, then help me to assemble every part of MIP. And I'll do that way. In each one part, I create a rectangle like this. The size of the rectangle is not necessary. You can do more extensive. Here I apply a radius to help CNC cut the hood easier without a sudden change direction. After the rectangle is complete, I have to copy and paste each rectangle and do it again for the bottom part. I create about 4 rectangles in every part. Okay, after a couple of minutes, this is the final result. After this part, I have to export the DXF file. I have 2 ways. I can export all that way, select the entire sketch, right click, save DXF, but I'll have a problem. When I open it with S.com, the program doesn't recognize the toolpath because there are some lines overlapped in the sketch, so he doesn't know to follow the correct shape. So to fix this problem, I use this easy method but a little long. Okay, I select the face and now I have to extrude another body a little separated from the beginning. To do this, I use an extrusion with an offset plane of 10 mm. For example, I also set 2 mm of extrusion and click OK. Now I have the perfect precise shape of the first body. When I'm going to export the DXF or SVG, I won't have that problem more. Now I repeat the same operation. I click the face, select extrusion with offset plane, set 15 mm and set 2 mm extrusion. Now I have to select new body and click OK. Now I'll do the same operation for all parts of MIP. Then I'll jump because I showed you the procedure. Okay, this is the final result. I divide the MIP into parts workable with a CNC 3018. Now I don't have the sketch about these parts, so I have to use another method to export the SVG. So to do that I use Shaper Origin, a program that can export the body or face contours in SVG file. You can free download this plugin on the Autodesk App Store. So I click Tools, Origin. I have to click on Single Solid Body in these windows. Select the face I want to export the SVG and click OK. I have to save it, and now he will produce an SVG file. I repeat the same operation for all parts, so I'll jump it again. It's very easy. After this, I open the SVG file on STLCam. I click Parts, click on these contours, cut the outer side parts, click Hole to cut inside that way, and these parts. After selecting or processing, I set the working parameters. Here I can talk about it. In my case I use a CNC 3018 with a 500 watt spindle motor. And then I can push it a little bit further, the CNC with a series spindle. Also I use a high quality end mill. Then I can use high value parameters than economic mills the constructor gives to me. These values are not the same for all machine. You have to adapt to your machine's type structure. You have to check the CNC at work and also if he can working quietly without extreme vibration. If he vibrates, you have to reduce the parameters. For this processing I use 5 mm step down and 450 feed rate. For the plunge I go more slowly. I set 120. The mill is 3 mm. I go to File and save the CNC program. So now I have to set the hood thickness I will work. It is 10 mm and click OK. Now it opens to me a simulation of the processing that the CNC will do it. I click OK to show it. I repeated this for the other panels. I show you quickly again. Click Parts, select the toolpath. For the inside processing, click Hole, select again toolpath. Also, the holes and the annunciator's holes set the same parameters and save the G-code. I put the thickness hood and click OK. For me, the most important thing is watching the simulation to have a preview, that way you will be sure the CNC will do the processing as you want. Okay, I did it. I must tell you an important thing. It is an experimental method. It is an experimental method. I thought it would be the most adapted for this processing because I could have some problems. I thought assembly these parts that way would be a good idea. After I do it all, I have to check the MIP stability when I glue it. I have to consider the CNC, it has high precision, because for each part I have just, for example, 1 mm error. This millimeter added up on other 19 parts in every part, I have a big mistake at the end. So in the following video we'll show how to create and assemble every part. But I had to advise you that this video I'm recording now should be subject to change, because if this method doesn't work or if I will have to do some update at this method, this video couldn't be helpful for you. Surely I'll keep you updated if something will change. Meantime, I try to use this method to see what will happen. As always, I thank you for watching this video. Give me a like and write me down in a comment below what do you think about it or any questions. If you are not already seeing it up on my channel, subscribe and activate the bell, so you will always keep updating every time I upload a new video. So thank you again and see you soon at the next video. Bye bye.